Good day, viewers. This is Ademola Johnson, your science tutor. We are still continuing our topic on periodic table. Today we want to look at classification of elements in the periodic table. So here you will see written here, I said elements in the periodic table are classified as follows. They are classified as families, as periods, as blocks, as metals, non-metals, metalloids, transition elements. Then let's take them one after the other. Let's talk about classification based on families. So we have 8 families in the periodic table. The first family we have is group 1 family. You have group 2 family. We have group 3 family. We have group 4 family, group 5 family, group 6 family, group 7 family, and group O family. So we'll start talking about group 1 family now. Group 1 family. This group 1 family is also known as alkali metals. Alkali metals. They are also known as alkali metals. So let's look at the features. The features of elements in group 1. In group 1 are number 1. Like we have already stated, we said that they are all called alkali metals. Before we go to that, let's look at the examples from this table. This is the vertical column here, the first vertical column here, labeled I. It contains hydrogen, lithium, sodium, potassium, and so on, like francium. You see, have some other ones that we have not mentioned here. That our table is only taking care of the first 30 elements. So take note of that. So now, number 1 thing to know about them is that now they are monovalent. Oh, sorry, they are monovalent. They are monovalent. They have monovalent atom. What does that mean? When they form ion, they carry one positive charge. For example, we have if hydrogen atom wants to form hydrogen ion, it loses 1 electron. So and it carries 1 positive charge. The same thing, lithium can form lithium ion and lose 1 electron. Then sodium can form sodium ion Na+ and lose 1 electron. Potassium can form potassium ion and lose 1 electron. So they all carry 1 positive charge. That 1 positive charge makes them monovalent because that charge they carry is their valency. It is same of saying that they have 1 valency. So that is number 2. They are all metals. Why? With the exception of hydrogen, which is a non-metal. So now, hydrogen in group 1 we have hydrogen, you have lithium, you have sodium, potassium, and like that. But hydrogen is number 1, is the only member of group 1 elements that is a non-metal. Every other members are metals. So take note of that. Then number 3 thing to know is that why are they metals? When we get to metals, we talk about that. Now, another thing to know is that they are monoatomic elements. They are monoatomic elements with the exception of hydrogen, which is diatomic. element. Now, what do I mean by that? When you are writing an equation and you are involving elements in group 1 as a free element in that equation, you write them without putting anything down. Like here now, sodium is standing, nothing is put here. Potassium is standing, okay. Potassium is standing, nothing is put here. But if it is hydrogen, one molecule of hydrogen must be written as H2. This to means one molecule of hydrogen contains 2 atoms. So that is what we mean by that. Then another thing to know about them. Now, so number four is that they are solid at room temperature. With the exception of hydrogen, which is gaseous. Hydrogen is the only gas. Every other thing, being a non-metal, so every other thing like lithium, sodium, potassium, they are solid at room temperature. Now, let's look at another thing here. Let's go to family. Now, that's number 5 now. Let's look at number 5 point here. Why are they called alkali metals? Now, members of group 1 elements, members of group 1 family are called alkali metals. Why? Because they react with water to form alkali, and liberate hydrogen. An exception is hydrogen. No, hydrogen cannot do that. What do I mean? What is alkali? Alkali is hydroxide of elements in group 1. Hydroxides. So soluble hydroxides are alkali. What am I talking about? Sodium metal. Now, can react with water molecule. This is what I was saying. Sodium as a metal is solid. That's the meaning of this S. And it is monoatomic. You can see I'm not putting any number here. When it is standing alone, it's a monoatomic element. So, and if it reacts with water molecule, which is liquid, then what happens to it? Then they form sodium hydroxide and liberate hydrogen gas. So that is what we have there. So this sodium hydroxide now is what? It's an alkali. So that is why sodium now is what? Alkali metal, because it will dissolve in water to form alkali. The same thing can happen to lithium. Lithium will react with water, liberate hydrogen and form lithium hydroxide. So then potassium will react with water and form KOH plus hydrogen liberated. Then it is also what? Alkali metal. Now, then let's go to group 2 family. Group 2 family. Now, let's look at the features. Number 1 thing to know. Features. Number 1. Now, they are called alkali earth metals. Why? As they react with what? They react with water to form, with water moderately They react with water moderately to liberate hydrogen, and they also form alkali. So they behave similarly as alkali metals, only that alkali metals do their own vigorously, but they do their own moderately. That is why you have to put the word "ent" before you write them. So now to liberate hydrogen and form what? And form alkali. So we have calcium solid can react with water liquid and liberate hydrogen gas and form calcium hydroxide, which is aqueous. So then in that case, to balance this equation now, I have 2 hydrogen here, I have 2, that's 4, so I need to put 2 here, so equation is balanced. So the same thing, so the number 2 thing to talk about here, you know, now I have told you something before that I have said in the previous video, so I don't bother to talk about it again. You should know that members of group 1 element, what do they have in common? When you write their configuration, all of them have valence electron, outermost electron of 1, 1, 1. Hydrogen is 1, lithium is 2:1, it end in 1, sodium is 2:2:1, it end in 1, potassium is 2:8:8:1, it end in 1. All of them have the same valency of 1. Then group 2 elements, beryllium, magnesium, calcium, you have 2:2, it end in 2. That's why it's in group 2. Then 2:8:2, it end in 2. That's why it's in group 2. Calcium is 2:8:8:2, it end in 2. That is why it's in group 2. So I have said that one in the previous video, so that's why I'm not bothering myself to talk about that again. So now, another thing to know about them is that they are divalent elements. Divalent elements, they have 2 valency. When calcium ionizes, let me use magnesium now. Magnesium solid, it ionizes to form magnesium ion after losing 2 electrons. So you have this, they are divalent. Where did I get this thing? You know, magnesium now is 2 to 8 to 2. What is here is 2. If what is here is 1 or 2 or 3, they will always lose it because it is not up to half of 8, which is the maximum number of electrons that this shell can carry. So they lose it and form what? 2, and they have valency of what? Of 2. So that is what I mean there. So number 3 is that they are solid at room temperature. They are solid at room temperature. Just like alkali metals. They are solid at room temperature. They are monovalent. They are monovalent. Monoatomic in nature. They are monoatomic. They have 1 molecule of a group 1, group 2 element has 1 atom. That's why when I'm writing calcium as standing on its own here in this equation, I am not putting anything here. So like when I'm writing hydrogen on its own, hydrogen has 2. 1 molecule of hydrogen contains 2 atoms. So hydrogen is diatomic. But these ones are monoatomic in nature. So they are monoatomic in nature. So take note of that. Now, so we are through with that. Now let's now look at okay, here we say they are mono here. They are all metals here. These ones are all metals too. They are all metals. They are all metals. They behave as metal. They have all the properties of being called a metal. So take note. Let's go to group 3 family. So the group 2 family we are talking about now contain beryllium, magnesium, calcium. They end in 222. So let's go to group 3 family now. Group 3 family. This group 3 family is also called boron family. Boron family. Also called boron family. So that's group 3 family. It's also called boron family. Let's look at it. Now, this is group 3. I told you between group 2 and group 3, there is a space occupied by transition elements. And this group 3, you have boron, you have aluminium, you have some other things. So, but this one is capturing the first 30 element. So, the first element there is boron, B. That's why it is boron family. Now, number 2 thing to know about them, we have all seen aluminium roofing sheet before. The one we use to roof our house. What is the state of matter? So, they are solid at room temperature. They are solid at room temperature. They are metals, while others are metalloids. We are still going to talk about that one later. What we mean by metalloids, we'll talk about that. Then number 3, another thing is that they are monovalent. They are monoatomic, not monovalent, monoatomic in nature. That is, one molecule of theirs has one atom. So when you are writing any equation involving any of them, you must not put, just like this one, you must not put any number here. So they are monoatomic. Number 4, they are trivalent. Trivalent in nature. What do I mean? They have valency of 3. Aluminium, for example, is solid. It's standing on its own. If it forms iron, it forms Al3 plus and loses 3 electrons. How come? Now look at what I'm saying here. All of them, all M members of group 3, they end in 3. Boron is 2:3. Aluminum is 2:8:3. This 3 is not up to 4, which is half of 8 that the outermost shell can carry. So they lose it. After losing it now, it will now carry the charge of what is losing. That's 3 plus. And the electron, so 3 electron is lost. So then their valency now is what is 3. So that is trivalent. So in nature. So that is their own nature. Now, then what else do I need to talk about them? They are solid. Okay. Now, yes. Then let's talk about group 4 family. Group 4 family. Group 4 family is also known as what? Is also known as carbon family. Carbon family. Now, let's look at their features. Number 1, carbon. How many of you have seen charcoal before? Charcoal, when wood burns, that black solid you see is carbon. That is charcoal. Or when you kill a goat and you burn it, and after burning it, look at the air. The air turns black. That black is what is carbon. Another carbon you have, if you cook rice and it gets burnt, that black solid you scrape at the bottom of the pot is carbon. So from all this description I've given to you, you will know that they are what? They are solid at room temperature. They are not gaseous. Then number 2, they are tetravalent in nature. What do I mean? Carbon, solid, can do what? Can gain 4 electrons and form C4 minus. So which is that? So you can see that here now I'm putting minus. What do I mean by minus? Now look at them. You have in group 4 you have carbon, you have silicon. They all end in 4, 2:4. That's why they are in 4. 2:8:4. Because of this 4, they are in group 4. But look at it. This 4 is half of 8. So they can when it is 4. Now the elements do not want to lose it. They won't want to lose these 4 electrons, but rather they think of how many do I need to borrow and add to the 4 to make it 8. So you need to borrow 4 and add 4 to this. So borrowing, the sign of borrowing is negative. So that's why it carry 4 minus, meaning it has borrowed 4 electrons in addition to the what? To the 4 it has. Just be the 4 electrons it borrows, then they form this ion. So it is tetravalent. Then another thing about them is that they are monoatomic. So when you are writing them in an equation, you should not put anything down like here now. Don't say C2. Just write C. So that's what we have there. So they are monoatomic in nature. So take note of that. Now, then let's talk about group 5. Group 5 family. Group 5 family. What are they? Nitrogen and phosphorus. Because nitrogen is number 7, 2:5, it ends in 5. Phosphorus is 15, 2:8:5, it ends in 5. For ending in 5, for having valence electron of 5, they are in group 5. So what do they have in common? Now, number 1, take note of one thing. Now, nitrogen. Nitrogen is a colorless gas. Colorless and odorless gas. Colorless, odorless, and tasteless gas at room temperature. But phosphorus is a white, red, or yellow solid at room temperature. So these are the various allotropes of phosphorus. We have red phosphorus, white phosphorus, we have yellow phosphorus. So they are all solid at room temperature. So take note of that. Number 2 thing to know about them is that now nitrogen is diatomic, while diatomic in the sense that nitrogen is written as N2, one molecule, while phosphorus is tetraatomic. So we write P4. So one molecule of nitrogen is usually written as N2. That means it is what? Diatomic. While one molecule of phosphorus is written as P4. That is a tetraatomic in nature. So that is what we are talking about there. Now let's go back to board 1. Now, let's now go to group 6 family. Group 6 family. Members of group 6 family are what? Oxygen and sulfur. And this family is also called chalcogen family or chalcogen family. They are also called chalcogen family. Let's look at their features. Number 1 feature. Let's talk about oxygen. Oxygen is a colorless, odorless, and tasteless gas at room temperature. At room temperature. At room temperature. But sulfur is a yellow solid at room temperature. So room temperature means the temperature, ambient temperature. Temperature when you are not heated and you did not cool. So that is that. Number 2. Now oxygen. Oxygen is what? Is is a divalent element. So it must be written as O2. While sulfur is is monovalent. Both of them. While sulfur is also divalent. It's either divalent or hexavalent. While sulfur is either divalent, when you write it as S2 minus in sulfide, or hexavalent, that's S6 plus. So what am I saying here? Sulfur is 2 to 8 to 6. You can decide to borrow 2 more to this C to make 8. Borrowing 2, it forms S2 minus. You can decide to lose the whole of this 6 and have S6 plus. So that is that. Now, then number 3 point here is that they ionize generally by gaining 2 electrons. So oxygen, one molecule of oxygen, one atom of oxygen we gain 2 electrons and form O2 minus. Then when it becomes a molecule, O2 now, gas, and multiply the number of atoms by 2, and those will be 4 electrons. Then to give us what? 2O2 minus. So that's what we have there. Now, so that's that. But sulfur can do otherwise, can decide to lose 6 electrons. We have said that. So that is that. Now let's look at fissures. Fissures of group 7 family. Group 7 family is also known as halogen family. Halogen family. It's also known as halogen family. Now, if in an exam they ask you to give us examples of halogen members, what will you say? Those members that their configuration end in 7. Like you have seen there, you have fluorine, you have chlorine, you see have some other members like bromine, like iodine, like astatine. So now, then what will you say about them? Number one thing to say here is that they are what? They are group 7 elements as their atoms have what? Have 7 valence electron or outermost electrons. You can see what I'm saying here. 2:7, 2:8:7. Number 2, they are diatomic elements. So if you want to write them, you can write Cl2. You can write F2. You can write iodine 2. You can write bromine 2. You can write astatine 2. So when you are writing them, one molecule of any member of halogen has 2 atoms. So that is that. Then another thing is that they are monovalent. They are monovalent elements. So when look at chlorine, for example, one atom of chlorine, we gain 1 electron and form what? Cl minus. So now, if it is now one molecule of chlorine which is Cl2, since I multiply chlorine by 2 here, now 2 electrons will be involved, and we have 2 Cl minus. So now, I want to tell you one thing. There is one question here. That question is that they will ask you, then before I go to that question, okay, the question is that which of the following elements can conveniently be put into two groups in the periodic table? The answer is hydrogen. So take note, hydrogen can conveniently be put in two groups in the periodic table. Now, how? What do we mean? What are we talking about here? Does it make any sense? Let's check. So I've seen that question several times in JAM. It says, which of the following elements can conveniently be put into two groups in the periodic table? And the answer is what? Is hydrogen. Why? Now, the reason is that hydrogen in group 1 can lose one electron and form what? And form hydrogen ion, which is H plus. So we have H, one hydrogen atom can lose one electron, can form H plus after losing one electron. Then if you know hydrogen is diatomic, you have H2 now. You now become 2H plus 2 electrons. So you form hydrogen ion here. The same hydrogen in group 7 can do what? Can gain 2 electrons. Can gain one electron and form hydride ion. Hydride or halide ion. So we have H, hydrogen atom, plus one electron forming what? Forming H minus this time around. Then if it is a molecule, H2, we gain 2 electrons and form 2H minus, behaving like hydrides here. So the answer, when you see a question like that, name one element that can conveniently be put into two groups in the periodic table. Answer is what? Hydrogen. So number 4 point on halide is that they are oxidizing agents. They are oxidizing agents as what? As they gain electron from what? From the reducing agent. To form halide ion. So take note of that, about that. So lastly, let's talk about noble gases. Let's go back to board 1. Features of noble gases or rare gases or inert gases. Now, features of rare gases, rare or noble or inert gases. Number 1, they have stable electronic configuration called duplet structure in helium. Called duplet structure in helium and octet structure in neon, argon, krypton, xenon, radium. So now, what do I mean? When you write their configuration, look at helium. Helium has 2 electrons, and that 2 electrons occupy K share. K share cannot take more than 2 electrons, and you have 2 there. But neon is 2:8. 2 electrons electrons in K shell, 8 electrons in L shell, and L shell cannot take more than maximum of 8 electrons, and you have the 8 there. So then argon is 2 to 8 to 8. This one cannot take more than 8 electrons, and you have 8 electrons at the outermost. So that makes it what? This is octet, octagon, 8, octet. Only this one is what? Duplet configuration. So why are they called inert gases? They are inert gases as they do not chemically react. Why? Why do they not chemically react? As they cannot, their outermost shell is full. They do not lose electron, they do not gain electron. Those other elements that react, their atoms are reacting to either lose electron, to gain electron, to share electron, so that they can have a stable configuration of duplet or octet like that of a noble gas. So they are the ones that every other element wants to look like. So they don't look like any other thing. Every other element wants to look like them. So they don't look like any other thing. So that is that. So now they do not chemically react as they do not lose, gain, or share their valence electrons. So take note of that. Then another thing to know about them is that they are monoatomic elements. When you are writing them, you write He, you don't put 2. You have Ne, you don't put 2. You have argon, Ar, don't put 2 under. So that is that about that. So now we are through about the families of elements in the periodic table. So now in the next video, watch out, we want to now look at other classification into periods and classification into blocks. See you next time. I remain my humble self, Afe Ademola Johnson. Please subscribe in my YouTube channel titled Afe Ademola Johnson, and share this video, like it, and subscribe. See you next time. God bless you. Bye for now. Thank you.